replicability. Sadly, I think they do sort of get used interchangeably. I'm just sort of making that distinction. But that said, I think sometimes if you look in computer science and more in the mathematical sciences, I think sometimes you'll actually see them used the other way. Because I came through initially as more of a classic bent scientist. So for me, replicability means to actually take the whole experiment and replicate it. So that sort of makes intuitive sense to me. But all right, let's see. Oops, data science.
Right. If I think of like psychology and all these people trying to, they talk about reproducibility crisis, but it's
right.
the same hypothesis in different groups.
Right.
Yeah.
So anyway, this is one study. If you guys haven't heard about it, it's been around. There's some fantastic talks. So there was a big study, and this has been going back about a decade or so. Duke had this massive clinical trial going on, actually maybe in a couple of trials, for essentially what they were doing, personalized medicine, trying to align cancer treatments by gene type. So, sort of this idea of targeted therapies based on certain phenotypes. MD Anderson, these gentlemen here, Keith Baggerly, and I think it's Kevin Coombs, reached out to Duke and said, hey, we'd like to try to, understand what you're doing and try to reproduce it. That kind of be an independent validator. And the guys at Duke said, sure. So they shared their files, and there's a lot of stuff going on here that's not just human mistakes, but there were some human mistakes that they found. And one of the biggest ones was a misalignment in the spreadsheet. So classic thing, you get data, it shows up in an Excel spreadsheet, and one of the first questions you have to tell the software is, does it or does it not have a header row? Like that first row, is that the name of the variables, or is it blank, or is it something else? Sometimes header material, can take several lines, right? So one of the things they found was a couple places where everything was off by one row. That meant patients were getting the wrong therapy. So that's a human error, right? I mean, it should be something that we're checking for, but it's a systematic error. So that was one thing, but they kept finding more and more things. Anyway, people really started digging into it. There was actually some ethical stuff going on, like a couple of guys lied on their resumes. Yeah, I think it even falsified some results. I mean, there was some bad stuff. So there's a whole bunch of legal action. Lots of things have been shut down. There's been all kinds of retractions done. So if you're interested, the link is here, the original New York Times article that came out, but then this video presentation by Keith Baggerly is fabulous. It really gets into the specifics and talks a lot about some of these issues, not so much the ethics, but the data science pieces. To the point now that there's a class I took 3 or 4 years ago on big data analysis, and one of the people said, yeah, it's become so tied to what Keith Baggerly and them found that the joke is now you don't want to get Baggerlied, meaning you don't want to get sort of caught with sort of these systematic problems. Another famous one, this one's more in economics, was the Excel error heard around the world. So there was this article that came out, I can't remember originally when this was published, about 2010 or so. Basically, these guys, Kenneth Rogoff and Carmen Reinhardt at Harvard, did growth in a time of debt. And so they had data that claimed countries with debt over 90% of GDP would experience slower growth, which makes a little bit of an intuitive sense, but turns out a few years later, Thomas Herndon, who was a 28-year-old graduate student at University of Massachusetts in Amherst, had a project. His professor said, hey, go find something, see if you can reach out, get a copy of the data set, and see if you can reproduce it. Like, this is a class project. Maybe his final project, but it was a class project. So he did. He reached out and wrote to these guys at Harvard, and the guys were like, yeah, sure, here's our data. And they sent him the file, and it was an Excel file with all the formulas and stuff. He got into it and found a major formula error. Now, this had worldwide acclaim. Like, I remember people in the sort of early 2000s talking about this because it was really a key thing, talking about, debt and, like, leveraging and all this other kind of stuff. It was sort of fascinating. So, but it turns out, somewhere there's a way to find this, but there's a picture of the Excel spreadsheet where some of the calculations that they were doing, they had only selected the first 40 rows, and they really should have selected like 70. So somebody just didn't drag the box the rest of the way to select that cell set of data. So they had excluded countries like Canada, New Zealand, Australia. So do you think that had an impact? It did. So anyway. So other things to know about. So I mentioned that about, there's another one that was done that said out of 53 landmark studies, only 6 or 11% had scientific findings confirmed. There is this whole group, though, the Center for Open Science and Open Science Collaboration. I don't know if you guys have talked any about that, but you might take a look at it. Now, their focus is a little bit more on this idea of replicability, basically being able to take studies and completely reproduce them and find similar, the same sort of conclusions. And so right now, at least in 2015, of the 100 studies, and this is a massive, almost like crowdsourced funding from like multiple countries and multiple organizations, they've really only been able to truly replicate about a third to a half of those studies. And I haven't looked up, I'm sure those numbers have been updated, but if you haven't heard about them, I encourage you to take a look at them. Some other things just to know about gene name errors. So this shows up more in sort of the microbiology side of things. But basically, Excel tries to be helpful. Oh, sorry, let me go back up. And they're changing these gene symbols and names into either dates or floating point numbers. So for example, SEPT2, which stands for septin2, and March 1, which is this membrane-associated ring finger. I'm not a biologist, so I don't know what that is. But basically, those are converted to the 2nd of September and the 1st of March. All right, we don't want that to happen. Now, honestly, right now, I could not tell you how to turn that off in Excel. There is a way to turn it off, but I suck at Excel, so you guys are probably smarter about than I am. There's something called Riken identifiers that are these really long strings of numbers. Those were actually converted to floating point scientific notation. So always, always, always know what your software is doing, regardless of what software tool you're using. Some other things, just kind of gives a breakdown of some of the things and where they've been published and the percentage of papers that had some of these auto-conversion gene errors. Some references here that are really good. So if you really want to understand this more at a policy level, I really encourage you to check out this first book, Implementing Reproducible Research by Victoria Stodden, Frederick Leisch, and Roger Ping. So Roger Ping's big reproducible data scientist, biostatistician. As a matter of fact, he's the associate editor for the Journal of Biostatistics for Reproducibility. Pretty big guy. Frederick Leisch is a key person in the idea of literate programming or dynamic documentation that I'll talk about. And Victoria Stodden is actually a lawyer. And so she really gets into some of the ethics and the issues of sharing and how we share and what we should share and all of the intricacies of that. These two books are by UEG with RStudio. The first one's Dynamic Documentation with RKnitter, which I'm going to show you today. And then the second one is Bookdown, which is how you can use all of these tools. And so the whole idea of like publishing online and making things just like ready and to the point and interactive. So that books aren't just static words on a page, that there's a lot of books now that are really truly interactive where you could actually go in and like run the code and do a demo and tweak things to see how the graph changes. So I think the whole area of data science education is it's just such a cool area. There's so many neat tools out there now. Jenny Bryant, for those of you that want to learn more and really understand what you're doing with Git and GitHub, take a look at this. This is an online book, Happy Git and GitHub for the user. The link is there. And it will walk you through how to log in, how to do the handshake, how to make sure that your computer is talking to the cloud and vice versa, and what to do when it all goes haywire and things get screwed up, which usually what I do is back it up, blow it away, and start over, fix files as needed. Nicholas Horton and Ken Kleinman have a really good book that's specific about data management and statistical analysis. Chester Ismay and Albert Kim, if you haven't heard of them, keep an eye on them. These are just a couple of their books they're working on. I think both of these are pretty close to being published. I need to update because they now actually have, title pages. They didn't have images when I did these. All right. And if I'm going too fast, I apologize. So literate programming and dynamic documentation. So you may have heard these terms. Literate programming probably started with Donald Knuth, but the idea here is that we want to communicate to humans, not so much, I mean, we still want to communicate to the computer, but we want things such that the program is more like a piece of literature because other humans are going to be reading it rather than trying to program something to a computer. Probably the end of that would be, anybody in here ever learned assembly language? That really is talking to a computer. I knew guys that knew that. I never quite went that far with my computer programming, thank God. So, as opposed to like where things are going now with R, with the whole tidyverse, where it's much more readable code. It has a logic to it. Frederick Leicht, who was a co-author in that previous book, he created something called Sweave, which is a way to link the data and the code and the documentation all together. And so the idea is you're weaving the code and the documentation together at the same time. Then a little bit later on, early 2000s, John Gruber came along and created Markdown. And how many of you guys in here have ever written like HTML, created a web page, ever gone in there and tweaked things under the hood? All right, HTML is hypertext markup language. XML is extended markup language. So Markdown was supposed to be a simpler, nicer, cleaner form, sort of a shorthand, if you will, for HTML. UEG came along in 2012 and released the knitter package. So remember I mentioned Sweave with Frederick Leicht, where we're weaving things together. Okay, it's a play on words. UEG came up with knitter, so it's like a faster, cleaner version of Sweave. And then our Markdown came in 2014, which is a flavor, if you will, of Markdown that works really, really well with R. Don't ask me to explain the nuances. I couldn't tell you. But it's similar, very similar to the original Markdown. Here's some more stuff about Sweave. The one thing I will say, anybody in here use sass, right, sass? There actually is a sass Sweave that still exists. So even if you don't know anything about R, but you know sass really well, you could potentially get into that and use Sweave to do that. Now, that said, the documentation piece on that assumes you know what you're doing in latex. So yet another thing you have to learn. So
Latex is what Donald made that when he
yes.
This is like, he thought he would write like a program, not necessarily just like data analysis, and you would have latex around it that you could write like equations with, right?
That's part of it. Part of it is that, and before WYSIWYG, what you see is what you get, editors. So I came along in the time of DOS. I'm really old. Anyway, everything was sort of command line. The guys that are like more Unix, they use VI. Anybody here use VI or Emacs? Anyway, but the focus is really on the content. And then what you do is you come back and you apply essentially desktop publishing, right? You say, okay, I want this to be the title. It's going to have this font face, this color, all that. I want this to be bold. I want this to be a header. I want this to be a bullet. You're applying this formatting after the fact. In Word and some of these others, we see it as we go, but there's a way to actually look under the hood, even in Word, and it's essentially basically using like XML or a variant, and you can actually see all of the formatting details that are in there, including all the page setup and headers and margins and all of that kind of thing. And that's really what LaTeX does. So LaTeX, you just see it. You can actually see all of the code and what's going on to format the document. So, but yeah, and equation, beautiful equations. I like them better than Word actually, but I know like this much LaTeX, just enough to be dangerous. So Knitter is an alternative to Sweave, and it's really nice, runs really well. Our Markdown, again, really hasn't been out here that long. The other thing that I will mention is it leverages pandock. So when I first started learning this about 4 or 5 years ago, you would download RStudio, you would install these different packages and stuff, but you had to install pandock separately. It was yet another thing you had to install. Now when you guys download and install RStudio, this all comes along with it. So this is happening behind the scenes, but just know you're getting it. If you want to learn more about it, you can go straight to the horse's mouth. But it's basically the Swiss Army knife for converting files from one format to another. And so these are a lot of the things you can do. You can move back and forth with PDFs, Word documents, HTML. There's a lot of ebook type formats. As a matter of fact, in the beta version of RStudio right now, if you're interested in downloading the preview and not the published version of RStudio, you can actually now make slides direct to PowerPoint, which I suspect probably here in the next 2 to 6 months. It just depends. Sometimes the beta versions take a while to get into publication. So I have a feeling later this year that will now be that'll be a standard piece inside of RStudio, which is awesome. All right, so RStudio Hub, I'll show you guys some stuff. But things to think about, just in terms of reproducibility, what could you do to make your own life better, right? What do you find yourself doing over and over again? All of your students, you probably have all at one point inherited either previous students' data or work, or maybe even your own from your advisor with less than stellar documentation, shall we say. So what would you try to standardize and make sure that it's available and people could reuse? And even if you don't do it for anybody else, just do it for yourself, because I haven't fully implemented it in all of my projects, but I had one project that I have to claim success on. Spent a lot of time on the front end making sure that I had everything connected between the files and the data and the code and the document and everything else. And it was a little painful at the beginning, but I only had a data set of like 30 samples. I had like 3,000 pieces of information that went with those 30 samples. But as the study went on, my pipeline was done. So with some tweaking, but for the most part, that pipeline was really good. And so when the next set of samples would come in, it would take me probably 3 or 4 hours on a morning just to sit down and make sure that everything was correct in the data. And then I'd run it through my pipeline, and I could have the report turned around by that afternoon. So that was fabulous. I'm not quite there on all of my studies yet, but that's the goal. A couple of other references if you're interested. 538.com, Nate Silver, done a lot of stuff on the election. Anyway, in the last 2-3 years, 538.com is now owned by ESPN, which is sort of interesting. I'm not really sure why ESPN bought them, but they did. Anyway, but they publish a lot of their stuff, so their stories that have the data and the code and the analysis behind it. Like, you can dig in and find that. And there's actually a GitHub repository for a ton of these. So I really encourage you guys to take a look at these. Some of them are pretty easy and straightforward. Some are a little more complicated. But and there's actually now an R package that allows you to tap into that just directly called 538. Telling stories with data. This is a couple of years ago at the RStudio conference, which if you guys can get the money and go, those are fabulous conferences. They're so much fun. It's very tight-knit. I mean, there's only like 2,000 or 3,000 people that go, and it's like all the key players, all the main guys and gals from RStudio and connected industries are there, and like very open, and it's a great experience. Anyway, Andrew Flowers presented this about, and I loved his theme, which was telling stories with data. Because at the end of the data in some ways is the artifact. And we're still interested in the question and, how can we use that and what can we use to visualize to tell the story. We already talked about journal biostatistics. This is another one that I really like. I got this out of that Implementing Research book. And this was in 2001. There was a deadly outbreak of this E. coli strain, killed 50 people in Europe. And so they pulled together these researchers at the BGI and this medical center in Hamburg, and they wanted to sequence the genome of the pathogen. And so given the severity, they wanted as many eyeballs and people working on this as possible. And so they put out a call via Twitter and established a GitHub repository to crowdsource all of the analysis and the research. And within 5 days, they actually had a bacterial agent proposed to kill the pathogen. That took a little bit longer to implement everything. But they had people contributing in less than a day, and within 5 days, they had a viable solution. So I really highlight this is not just for the comfort and convenience of all of us, which it is, but it truly can, like, save lives. So that story just, like, blew me away when I saw it. It's like, oh, my God, why is this not all over the news? I mean, this is just so cool. All right, I won't go through the rest of this. But the key there is this idea of combining data, code, text, figures. Matter of fact, there was somebody I was talking to. She's worked on this large immunology project with looking at flu and all of the different strains and stuff, and so they published this like massive set of reports. And before those reports went out, they had to sit down with every single one of them and had independently verify all the tables and the figures and so forth, and show that they could reproduce all of them. And they said out of like, I don't know, something like 13 reports, 12 of them had errors. No, not huge errors. Could have just been like formatting and some things like that. But like in every single case almost, there were little things that they couldn't quite completely replicate. Biggest place that you find things is the cut and paste errors. That happens to me all the time, or you have the output over here and you're typing something in a document. I can't tell you the number of times I accidentally like type 0.5 instead of 0.05. You know, I mean, it's just easy to do. All right. Flexibility, transparency, these are all really important. I encourage you to take a look at this research compendium example with the RRR package. I won't go through the rest of this. We've already talked about it. But the one thing I will say is increased visibility. So in addition to making your life easier, if you do provide and can publish things and provide these resources to others, you become the subject matter expert. So it's also really good because of the transparency piece, goodwill, and communication with the public. All right, how? All right. So I'll do a little demo here with GitHub, but you know, you can still do things with Dropbox, Google Drive. There's a number of data repositories. These are just two examples. In addition to GitHub, because I don't know how many of you knew GitHub got bought by Microsoft, there was a whole bunch of people that said, that's it, I'm out of here, and they moved immediately to Gitbucket. But there's a bunch of these others, Dryad, Figshare. You're starting to see these show up more and more in publications, because at the end of the day, they'll just be like, okay, you know, these are the things we're highlighting, but all of our stuff is available via, and so they're using these repositories in conjunction with publications. All right, stakeholders, yourself. But like I said, more and more journals are almost demanding this now, so be on the lookout for that. Books, blogs, websites. OurPubs, any of you guys played with that? So if you haven't done much with GitHub, OurPubs is a gentle introduction. So inside the RStudio window, and I can show you this in a minute, there's actually a little button that you can click. I don't know if anybody's ever seen it. It says Publish. If you click that button and you have an account, OurPubs is free. It will publish whatever you're working on OurPubs. I mean, there are instructors now that actually say, just publish your stuff on OurPubs, send me the link, and then like people, you'll find all kinds of people's homework out there. So, and it's really fast. It's just you're generating an HTML file that gets uploaded to the OurPubs server, and it's a free resource. There's some others. I also encourage you to take a look at Bookdown. I'm just going to go ahead and open this for you so you can see. This is the Bookdown book, but the root here is bookdown.org, and there are all kinds of free books. So here's the Bookdown book. Here's text mining. Any of you guys interested in text mining? I know we had that lecture in the fall on web scraping. This is related. Here's the book on R Markdown. Bookdown. So there's a ton of these. Here's Roger Ping's book on data science, the Advanced R book by Hadley Wickham. Anyway, so, and these are all online. I'm interested to talk to publishers to find out how people are getting away with this. Like, how do you let people have a full book online and yet you still have a book in print? And anyway. Oops. Okay. All right, so this is basically the environment. These are the pieces. The one thing that I will say here about the programming and analysis with R, so inside RStudio, and they keep adding more to it, So I think I might have seen a couple of hands. People in here, a couple of you guys doing Python too? So you can actually use RStudio as your interface to Python if you have Python installed. So you're allowed to do that. And it's not published as part of the documentation in RStudio. There's actually a plugin for sass as well. So if you guys independently, anybody wants to know that, just email me and I'll send you the stuff on sass. But there's actually now, it's like sass, sass Markdown or it's something like that. I can't remember the package name off the top of my head. But I have a feeling we're going to see more and more and more of this in the future, so that RStudio as an interface is not just going to be for R. It's going to include a lot of other things. All right. So let me just take a second and open my R project. Okay. So inside RStudio, if you guys haven't ever played with this that much, in addition to the usual things that you can do with writing programs and sort of managing your process and so forth, so in the file, you can create scripts. There's also something called R Notebook, which is a lot like the Jupyter Notebook, Python notebooks, where it sort of combines the code and the output. It's very interactive, right? It's the idea of the electronic log notebook. But you can come in here, and if you guys have it, if you haven't ever played, you can actually click on New R Markdown File. And the cool thing with this, in addition to sort of creating documents, so you can create HTML, Word documents, and PDF. The one caveat I'll say with PDF does require you to have some kind of LaTeX program engine installed. I've played around with it. There's a MicTeX and a MacTeX. Those are one's for Mac, one's for PC. But UEG also in the last year came out with a package called TinyTeX, TinyTeX. And if you download and install that package, you can do that all inside RStudio, and it installs a very, very lightweight LaTeX processor. And once that's installed, then you can go and knit to PDF. So just keep that in mind. You don't have to install a full LaTeX package if you don't want to. I never know if it's LaTeX or LaTeX. So my apologies to anybody. I'm mispronouncing it. LaTeX. Okay. I know it's not latex like the gloves. I mean, but yeah. I've also heard latex, but anyway. Under presentations, and this is continuing to expand. Matter of fact, I'm actually surprised there's a really hot format right now called oh shoot, I'm gonna forget it. Anyway, but there's more and more of these presentation formats coming out. But there's two here, IO slides and Slidey, basically are HTML5 formats. You can also go to PDF if anybody is familiar with Beamer. Have you guys ever talked about Shiny? Y'all ever do any workshops on Shiny? Not yet. If you're interested, this is an area that I'm still learning too, for this idea of building much more of an interactive interface. This is one way to get started with Shiny. The other thing, and I wasn't going to demo these today, but there are these templates. And I just recently updated my RStudio, so I haven't reinstalled. There's a package out there called Articles, which is RTICLES. And if you install Articles, then when you go here from template, it actually has templates for publishing to like the Journal of Statistical Software. Or I think there's a couple other statistical journals. There's some Elsevier journals, a lot of the PLOS journals now. So if you're writing to one of those, you can actually put your whole manuscript together, save it with their template format, and just ship it straight to them. And the cool thing is when you process it, basically you're like printing and saving to PDF, it's going to look just like it looks in the journal, in the final published format, which is really cool. So I have a feeling this is going to continue to get developed. All right, so when you create these, I've got two that I had in my files. So this first one is a report. And so there's a little bit of information at the top. That's called YAML. which stands for yet another markup language. But it has basically some header information, right? My name, the title, a date, and it tells me that I'm going to an HTML output format. Then the rest of the stuff that follows here, and I'm going to just minimize this so you guys can see it. So there's a little bit of stuff here in between these little backtick marks. That's our code. So what I'm doing here is I'm sort of setting up my document. The knitter options there are just doing some things, telling me, like, do I want to see my code? Do I want to see the output, or do I want to hide that? For the most part right now, I set it all to false because I'm hiding things. If I was debugging, I would set all this to true so I could see all of the issues. I'm loading my libraries, all my packages. Then this part here that's outside the R code. So I've got documentation, right? So I've got code plus documentation. This is the Markdown piece. So the double hashtags here for abalones tell me this is a header. It's a level 2 header. If I wanted a level 3, I'd just add another hashtag. And then I've got some text. This piece in here is a URL, so I've got a hyperlink. Then I've got some words offset here with double asterisks that makes it bold. So there's this whole like language and markup and stuff, and if you want to learn more, there's tons of stuff online, but there's this quick Markdown reference, and it'll show you some of the formatting. So like we can make lists, we can make itemized things. There's manual line breaks, links, images, quotes, and so forth. And then what I'm doing here is I've got a data set. I've already got a data set loaded, but there's ways to actually, if I wanted to, I could read a data set off the web. I could pull it from Google Drive, maybe Dropbox. I can't remember if there's an API for Dropbox. There probably is. Anyway, so I'm reading in the data, and then I'm going to start doing things with it. And so one of the things, this piece that's here, I've actually got our code embedded in the sentence. And what it's doing is it's actually going out and calculating the average whole weight of these abalones, and it's computing the standard deviation. So imagine I'm doing this, and I've got something, it's an ongoing study, and maybe a year later, I get more data. Don't have to change anything here. All you have to do is click a couple of buttons, maybe change the original file name, and click Run. So let me show you what this looks like. So if I take this and click Knit to HTML, did I click the right button? Oh, it's running. Sorry, I had it hidden. So what you didn't see here is it's actually processing the document. There's a little note here that says pandock. So it actually is running pandock under the hood. And when it finishes, here's my report. So here's the HTML, and so it has this. Here's my link. These two words are set in bold. I've got a table here with a bunch of summary statistics and a plot. And what's cool, suppose that I decided, I came back up here and I sort of built this in last night. Let's say I hide that and instead decide I want to run this with just the males. So what I'm doing is I'm filtering out everything except for the male abalones, and now I can click Knit to HTML, and it's going to rerun this whole thing in just a couple of seconds. Now I've got an error. Figures. Never do these things live. Oh, I know what I did wrong. Sorry. I have to leave. It actually still has to read in the file. Sorry. I need both lines of code. Okay. And by the way, there are a whole bunch of other things. I encourage you, if you really want to learn this, get the UEG's book and read through the our Markdown book. And there's ways to actually make this interactive. It actually embeds a little piece of shiny code, so I could actually have something when I go to knit it. I say knit with parameter, and it would come up and go, okay, what do you want me to knit? Do you want me to do the females, the infants, the males? You can imagine, let's suppose we had it where we had data across multiple years. You could run separate reports for different years, maybe different regions of the country, or any combination of the above. So it makes it really awesome. The other thing is, you can standardize. So just like I have this, where I was knitting and processing out to an HTML document, I could also make a presentation. And so there's a few little minor things that are different, but for the most part, this document looks identical to the one I just did. But now if I knit to the IO slides, these slides are going to look an awful lot like my presentation, which is the format that I was using for the slides I just showed you guys. And it opens in another viewer window here. So here you go, title slide, a little bit of information. By the way, this data set that I'm playing with comes from the University of California, Irvine, their machine learning repository. So if you guys are looking for data sets to play with or you need one for a class, check out this repository. They have some really cool stuff. And it's not all medical related. I mean, they have things all over the place. They have, if anybody ever seen the wine classification data set, that's in there. I mean, Fisher's iris data set's in there, some of the classic ones, but there's some really neat ones too. But this abalone data set is in there. This is where I'm calculating something on the fly, and so there's the mean and the standard deviation for the whole weight of the abalones. I just showed a partial table and then a scatter plot. And so, I went too fast. Hold on. I'll do this one in HTML again. So in the viewer window, I mentioned OurPubs. I haven't logged in a while, but I can show you what it looks like. So up here at the top, there's a little button that says Publish. And so if I say Publish Document, I think it still works. Okay, I have to install packages. This is the downside of upgrading before you do a demo. I won't take time to do that. But one of the things it'll pop up and say is, do you want to publish to OurPubs? And there's another one. I think RS Connect. There's an RStudio Connect. I think normally you have to pay for that, but there may be an educational discount where you can like publish to like an RStudio server kind of thing. Let's see. Just on the fly, I could change this. So it'll happen really fast. As soon as I click knit to Word, the output line will change slightly. Now it says Word document, and it's processing down here. And when it finishes, it should pop up in kind of a Word viewer. Now this assumes that you have like a version of Word installed on your computer, but so I'll turn that off so you guys can see it. So there you go. Some of the tables don't work exactly the same. I probably would need to clean up the tables, but anyway. All right, I'm going to stop there and take questions. Anything else you guys want to see, ask questions before I have to run to back to the other side of campus? and feel free to download this, play with it, hack around on it. So, cool. Yeah.
So when you're knitting Markdown, are you sort of limited to the RStudio environment? Because I'm wondering, so like I use R mostly on the terminal, and so I'm wondering if I had a Markdown that I created and that, you know, when I'm running a process, if I like add more animals, I want to generate a new like PDF of my output, would that I have to figure out some way to coordinate with pandock in order to run that?
No, it just when you're inside. So here's something else, and there's a lot of things going on under the hood, but what I would suggest is a couple things. One, have a dedicated project folder so that everything is there. Now that said, as you're going through your code, if you've got files that are in remote locations, you just need to know how to put the right code in there so that it knows, okay, I need to go and read this file off of like a network drive or something. The other thing to keep in mind is your environment. So notice right now it says my environment's empty. Well, I just did a bunch of stuff. So our Markdown documents on purpose start a brand new R session and then start processing from the top down. So you have to make sure inside that document everything you need is specified. So all the packages have to be loaded, not installed. You need to install them first, but they need to be loaded using the library statement. And then inside the code, you need to be able to tell it where all the data is coming from. That said, if you've got something that takes a really long time to process, so like imaging or video or something, you can have those already pre-processed and then like read in the processed file or something, because I know people in metabolomics and the microbiome and stuff, that there's a lot of stuff that can take a couple of days to run, and you want to save that. You don't want to start over at the beginning. So does that help? I'm not sure that totally answered it. The other option, if you guys haven't checked this out, I just recently did this for my class, and this is expanding. Go to ourstudio.cloud. So this is you can get an account for free. If you're teaching a class or can call yourself an instructor and you're providing a resource, then you can actually request to have more accounts and more projects. But just you on your own, you can go and set this up today for free. And when you go in here, you're allowed to create new projects. And so I could come in here and say, I want to create a new project. And this is all in the cloud. I didn't have to install any software. I just need a browser. You're now actually accessing an RStudio server. So when it opens, we'll see how long this takes, but you've got full RStudio. And guess what? You don't have to install anything to knit to PDF. All that's already taken care of. It's already on the server. So this is another way to do it, and I'm encouraging my students to test it out this semester. One, gives us a chance to teach some things if the students are still sort of right here at the beginning, kind of tweaking the software and getting everything working. But it also gives you an option if you are in a remote location and you're working on a computer that doesn't have that software, like say you're out at the research station and they don't have this installed, you could just log into your RStudio account and access your project that way. You'd have to look into the nuances of how to manage some of the data and things like that. So, and since this is free, I'm not exactly sure how secure that is. So, word of caution: anytime you put anything in the cloud, check all the privacy settings. But here you go. So we've now got a full R session, and I can do all the same stuff. So cool. Yes.
So I'm new to R, but are there limitations with like integrating Python code snippets or chunks into the R Markdown that can slow down the whole
I don't think so. So I will admit I have not tested Python, but inside our Markdown, so let's see, just create a new file. So if I came down here, there's a little button here that says Insert. So right now it's set up by default to insert, but I could click Python, and anything I type in between those tick marks after Python is Python code. Now it assumes obviously I've got a working compiler installed. So that's as much as I know. I really haven't tested it, but there's a ton of people doing exactly this. And I think you're even allowed within the same document to switch between code, because it does make the distinction. So like this would be Python code, that's our code. There may be some things you have to do as you switch, but you could have multiple things. There's even like SQL and other things that you can do with this. So it's a good question.
I mean, I was going to ask a question on the same line.
Okay, sure.
Yeah, I think that you kind of answered it, but for somebody, I use a lot of Jupyter notebooks, and I'm usually using Python in the notebook.
Mm-hmm.
And this, one thing you can't do in a Jupyter notebook, I like it because it's a bunch of cells. Some of the cells are like Markdown, but some of them are code. But the cells are live, so I can run them right away.
Yes. You don't have to. Actually, there's a way. So, for example, like right here, there's a little button that I could click Run. So it's gonna run and set some things up for me. And then if I come down here and click Run, it's reading. So notice it's like altering the thing. And if I click, well, I haven't been able to figure out how to run and display inline code. But like this, if I click it, it like sends the output to the screen. So there's ways. So here's an R Markdown notebook, and I'll admit I haven't, like if I click this, which plots cars is a built-in data set, it actually shows inline. So being able to have those inline chunks, that's awesome. You don't have that right now in a notebook, a Jupyter notebook, how these are. So okay, interesting. There's some way to get from R Markdown to a notebook, so you can have your perfect version of it. Trust me, there are people out there doing exactly that. There's all kinds of blogs and stuff, and I actually read a really interesting discussion the other day that was basically it's not Python versus R, but it was really how they could be used complementary to each other because they each have their areas that they excel in. So anyway. Yeah, sure. But one more quick question. I'm going to shut down while you're talking.